So today we are going to start a very important chapter of standard 11, that is redox reaction. Before going to this chapter, we will see certain history. In standard 9, there was one chapter, chemical reaction. In this chapter, we have studied certain type of chemical reactions. Like the combination reaction, then single displacement reaction, double displacement reaction. In that, there was one type of a reaction known as a redox reaction. This redox reaction, this word is made up of two words, that is red and ox. This red meaning is reduction and ox meaning is oxidation. So first definition of redox reaction is, in a chemical reaction, if there is an oxidation and reduction reaction occurring simultaneously, then such a type of a reaction is known as a redox reaction. Means, if there is any chemical reaction in which reduction and oxidation reaction occurs simultaneously, then such a type of a reaction is known as a redox reaction. So I will write down the definitions here. If in a chemical reaction, if reduction and oxidation reaction occurs simultaneously, then such a type of reaction is known as redox reaction. So here now we are going to study individually reduction and oxidation in detail. So the reaction meaning, here the meaning is, if in a chemical reaction, if reduction and oxidation reaction occurs simultaneously. The meaning of simultaneously is, if in a reaction, if reduction is occurring, then it should also occur the oxidation. These two processes should occur simultaneously. Then such a type of a reaction is known as a redox reaction. Now we are going to discuss in detail about here oxidation. So oxidation definition should be studied in three terminology. First, based on oxygen. Second, based on hydrogen. Third, based on electron. Fourth, based on oxidation. So first definition is based on oxygen. So oxidation in terms of based on oxygen is, if there is an adding of oxygen from reactant to product, such a reaction is known as oxidation. While going from reactant to product, if a species is added with oxygen, then such a type of a reaction is known as oxidation. We'll see the example. Suppose if I combine H2 and O2, so I will get H2O. If you see, this portion is reactant, this portion is product. While going from reactant to product, that is from hydrogen to oxygen. So hydrogen, here hydrogen, and here the oxygen is added to hydrogen. So such a type of a reaction is known as the oxidation. Another example, if you see, if I react with zinc with oxygen, I will get ZnO. If you see here, this Zn is alone, when you go to the product, oxygen is added to zinc. So such a type of a reaction is known as an oxidation. The next, if you see Cu plus O2. Similarly, here also if you see is Cu2O. So here Cu is alone, but when you go to the product, when oxygen is added, then such a type of a chemical reaction is known as oxidation. These are the oxidation reaction based on the oxygen, because the definition says if there is an adding of oxygen from reactant to product, so this portion is reactant, this portion is product. So while going from reactant to product, if there is an adding of oxygen, so such a type of a reaction is known as oxidation reaction. You can write down this. Then next, we can see next definition is based on hydrogen. So the definition of oxidation based on hydrogen is if there is removal of hydrogen while going from reactant to product, such a reaction is known as oxidation. So I am telling the definition of oxidation in terms of based on hydrogen. So it says like if there is a removal of hydrogen, in oxygen you are adding it, but in hydrogen you are removing while going from reactant to product. Same reaction I will take of water. See, H2O, H2 plus O. If you see this chemical reaction here, this oxygen is added to the hydrogen, and by going from reactant to product, hydrogen is removed. So this portion is known as an oxidation. Here. Next, if I say sodium hydride, when I do the electrolysis, so I will get Na plus H2. So you can see here while going from reactant to product, so there is a removal of hydrogen. So such a type of a chemical reaction is known as an oxidation. So what is the basic difference? The basic difference between based on oxygen and based on hydrogen for the oxidation is, for the oxidation reaction, adding of oxygen or removal of hydrogen while going from reactant to product, this type of reaction is known as an oxidation. So you have to understand, adding of oxygen or removal of hydrogen, this both process, either adding of oxygen or removal of hydrogen, this both process are known as an oxidation. Next definition is based on electron. This is very important because on this we will do many reactions. So based on electron, the definition of oxidation says if there is removal of electron while going from reactant to product. So the definition of oxidation, the based on electron, it says that if there is a removal of electron while going from reactant to product, means electron should be removed. As we know, who will remove the electron? The element whose outermost electronic configuration is either 1 or 2 or 3, or the metal. Base part is metal. Metal have a tendency to lose the electron, means they will undergo oxidation. You can see the example there. Sodium. Sodium atomic number is 11. Its electronic configuration is 281. So the outermost orbit electronic configuration is 1. So it will lose one electron, form a positive ion. So such type of a chemical reaction is known as an oxidation. or you can take beryllium. Atomic number is 4, so 2, 2. So it will use 2 electron, means it will get Be plus 2. So such type of a chemical reaction is known as an oxidation reaction. Okay. Now if you see here, you can see the net charge is here 0, and here also net charge is plus 1 and minus 1, means here net charge is 0. So the charge also should be balanced. This we will discuss in further classes. Another example you can take of any metal. For example, you can take aluminum. Aluminum atomic number is 13. 13 means 2, 8, 3. So you can see the outermost electronic configuration is electron is 3. So it will lose 3 electron and will create. So see that these are the certain examples of the oxidation based on the electron. You can copy out it. Next is based on oxidation number. This we will discuss in the further chapter. But just now, for understanding the definition, you will just remember the definition says 4 things based on oxidation number. So based on oxidation number, just remember the definition. For this, I will go with the oxidation number itself. I am writing in this way oxidation, you should not write it. So based on oxidation number says, if there is increase of oxidation number, if there is an increase of oxidation number while going from reactant to product, reactant going from reactant to product is known as oxidation. So we will discuss this oxidation number. Just write on the example here. Then you will be easily able to calculate the oxidation number. For example, if I write down here, I write down this reaction like Zn plus HCl. I will get ZnCl2 plus hydrogen. This is metal plus acid reaction. The Zn oxidation number is 0. Why? I will discuss later. And here the oxidation number of Zn is plus 2. So you can see here, this is Zn in the reactant side, this is Zn in the product side. So while going from reactant to product, I observe that the oxidation number increases. Such type of a chemical reaction is known as an oxidation reaction. And this is nothing but our oxidation number. Next example, if I see H2 plus O2, I will get H2O, balance the reaction. The oxidation number of H2 will be 0. The oxidation number of hydrogen will be plus 1. Why? I will discuss later. 0 to plus 1, again there is an increase of oxidation number while going from reactant to product. So such type of a chemical reaction is known as oxidation reaction. So this was the oxidation or definition of oxidation based on this 4 types. Similarly, now we will discuss reduction. Similarly, we discuss the reduction. Same, based on oxygen, based on hydrogen, based on electron, and based on oxidation number. You can remember one thing here, that based on oxygen and based on hydrogen, I told for the oxidation, that adding of oxygen or removal of hydrogen when going from reactant to product. So such type of a chemical reaction is known as an oxidation. In reduction, it will be reverse. So we will see the reduction portion. Next topic on reduction. So we'll see the reduction based on oxygen. So reduction based on oxygen says, if there is a removal of oxygen, in oxidation it was added, but in reduction is removal of oxygen. If there is removal of oxygen while going from reactant to product. Such a type of a chemical reaction is known as reduction reaction. This is a reduction reaction. So here the oxygen should be removed. For example, if I take water and if I do the electrolysis and get H2 plus O. So you can see there is a removal of oxygen when going from reactant to product. So such a type of a chemical reaction is known as what? Reduction reaction. You can see this. Okay. So this is H2O. Here hydrogen is attached with oxygen. But if you see here in the production oxygen is removed. So removal of oxygen. So such a type of a chemical reaction is known as reduction reaction. Next example, if I see I take ZNO. If I split it and get Zn plus O2. Such a type of a chemical. You can see here there is a removal of an oxygen while going from reactant to product. So such a type of a chemical reaction is the reduction reaction based on oxygen. Now next topic I will go, that is based on hydrogen. So in oxidation for the based on hydrogen was removal of hydrogen. But here it will be a adding of hydrogen. So next is based on hydrogen. Adding of hydrogen while going from reactant to adding of hydrogen. For example, if I take sodium, if I take hydrogen and form sodium hydride. So I am adding the hydrogen while going from reactant to product. So such a type of a chemical reaction is known as a reduction based on hydrogen. Another example, if I say H2 plus O and form H2. So this is oxygen is here alone. But when we go from here to here, there is an adding of hydrogen. So such a type of a chemical reaction is known as what? A reduction reaction. And sort of other examples will come in the chapter. So you can activate it. The next is based on electron. So third topic comes based on electron. So if in oxidation you have studied based on electron, the definition was if there is a loss of electron while going from reactant to product. But here the reverse case, that is adding of electron in reactant side is known as a reduction. Last class you have seen who will lose the electron. Last topic you have seen who will lose the electron? Metal. And here who will gain the electron or adding of the electron? That are non-metals. For example, if I take chlorine, the atomic number of chlorine is 70 and its electronic configuration will be 287. If you see the outermost orbit electron, there are 7 electrons and it requires 1 electron to become stable. So they will gain 1 electron and convert it into Cl-. So they convert into Cl-. So this reaction is known as a reduction reaction. Next example we will see phosphorus. Phosphorus is 15, 285. So they will gain 3 electrons and they will find the -3. So this is also a reduction reaction. You can see here 287. We have gained 1 electron. The electronic configuration will be 288. So it is stable. So this reaction is known as a reduction reaction. Similarly, they have gained 3 electrons. So it will be 288. So such a type of a chemical reactions are known as a reduction reaction based on electron. The next we will go to the oxidation number. So next is based on oxidation. I will discuss oxidation number after this topic only. So oxidation number, we have to write down the definition for reduction. In oxidation we have written if there is an increase of oxidation number while going from reactant to product. In reduction we do the reverse. That is, if there is a decrease of oxidation number. If there is decrease of oxidation number while going from reactant to example, same example, H2 plus O2 is what H2. The oxidation number is 0, 0, here it is plus 1, it is minus 2. You can see here the oxidation number of oxygen I have written here is 0 and here I have written minus 2. So 0 to minus 2 there is a decrease. So this reaction is known as the reduction reaction. Okay, next example you can write down Zn plus HCl, which I have written from the ZnCl2 plus hydrogen gas. You can see here the oxidation number is 0, here it is plus 1, here it is minus 1, here it is plus 2, here it is minus 1, here it is 0. You can see here the hydrogen oxidation number is plus 1, but here the hydrogen oxidation number is 0. So there is a decrease from this to HCl to hydrogen plus 1 to 0. So this reaction is known as a reduction reaction. So these are the definition of oxidation and reduction separately. So now we come to the point, what is this redox reaction? Once more, if in a chemical reaction, if reduction and oxidation reaction occurs simultaneously means if there is an oxidation, there should occur reduction, or if there is an oxidation, there should occur reduction. And such a type of a reaction is known as a redox reaction. Another example, for example, H2 plus O2. H2. See here, hydrogen, it's alone here. This is adding of oxygen, this is oxidation. This is oxygen, adding of hydrogen means reduction. So this reaction is known as a redox reaction. First example. See, if there is an oxidation, there will be a reduction. So simultaneously means if there is an oxidation wherein the reduction should occur. So such a type of a reaction is known as a redox reaction. This is an example of redox reaction. Another example, Zn plus HCl gives ZnCl2 plus hydrogen. I write down based on oxidation number 0, here plus 1, here minus 1, plus 2, minus 1, 0. You can see here 0 to plus 2, increase of oxidation number. So this is oxidation, and plus 1 to 0. So this is decrease of oxidation number, so reduction. So this is an example of redox reaction, and many more examples are there which will come in the further classes.